In this section, we'll look at some properties or laws of logarithms. Now remember that logarithms are just inverses of exponential functions. And we already know there's a bunch of properties for exponential expressions, like when you multiply two expressions that have the same base, you add the exponents. When you divide, you subtract the exponents. When you have a power of a power, you multiply the powers. Because of those properties and because of the relationship between exponential functions and logarithmic functions, we get these properties or laws for logarithms. The product law says the logarithm of a product becomes the sum of the logarithms. Log of x times y becomes log of x plus log of y. The bases all stay the same. Log base b of x over y will equal log of x minus log of y, all the same base. The names of these laws are based on the left-hand side of these identities. And then the power law says log of x to a power p is equal to p log base b of x. Some people also call this one the wraparound rule, or the wraparound law, or as one of my colleagues calls it, bring the cat down from the tree. So you see something up there, you can bring it down to the side and write it on the side as a coefficient. Of course, these would only make sense if the numbers or expressions you have inside the logarithm are in the domain, which means x and y have to be positive. And we can use these laws or identities in both directions, going left to right or right to left. So if you have log of a product and you write it as a sum, we say you're expanding the expression. But if you have the sum of two logs and then you write it as a log of a product, we are combining the expressions, sometimes also called condensing the expressions. So first, let's just do a couple of examples so you can see how this can help us evaluate some logarithmic expressions with just numbers. Log base 6 of 4, I don't know what that is because I don't know 6 to what power gives me 4. Same thing with log base 6 of 9. I don't know what that is. It's not a whole number I can see in my head. 6 to what power gives me 9? I don't know. But we can use this property right here, and we are going right to left in that identity. We have a log plus another log with the same base. And we know that we can write it as one log. We can combine them or condense them into one log, and we multiply the arguments. So that gives me log base 6 of 4 times 9, which simplifies to log base 6 of 36. And this I can do in my head because I can answer the question. 6 to what power gives me 36? And the answer is 2. In the next one, we are subtracting two logarithms that have the same base. So I can use the second property, the quotient law, but we're using it right to left. We have the difference between the two logs. So we write it as 1 log, same base, and then we divide the first argument by the second argument. 135 divided by 45 is 3, so this becomes log base 3 of 3. And 3 to what power gives you 3? The answer is 1. So that's one way you can use these properties. You should also be able to expand logarithms with numbers and variables. And this is something that's actually going to help you, something that's very useful in calculus, to be able to expand these. Now, it's important to remember all those things we said, for example, the property that allows you to rewrite. This is one example of a property you should remember about exponents, that nth root just means 1 over n power. So ln of square root of ab can be written as ln of ab to the 1/2, because square root means 1/2 power, and it's on top of all of AB, not just part of it. And then we can use that third property that said log base b of something, and it doesn't matter what that something is, to a power can be rewritten with the power wrapping around to the side, or bringing that cat down from the tree and put it on the side. So we get 1/2 ln of AB. Well, this is still not completely expanded because I can use that first property, the product law or the product property, to expand this. Ln, which just means log base e, it's just an example of a logarithm, of a product is ln of the first factor plus the ln of the second factor. So this can be written as the 1/2 times ln of A plus ln of B. And we can then distribute that 1/2. So we've completely expanded. When you expand a logarithmic expression, you don't want any products, quotients, or powers inside any logarithm. For the next one, there's a few things happening. We have a y cubed on top. We have square root of 2x on the bottom. So first we can use that quotient law and break this up, expand it. And remember, log by itself means log base 10. We just don't write the 10. So quotient property tells us we can write this as log of top minus the log of the bottom. But this is not considered completely expanded yet. We can't have any powers on any variables that can come out, and also no products or quotients if we can simplify. So the power 3 can wrap around, bring that cat down from the tree, and come to the side, and that gives us 3 log of y minus, and then this one, remember, square root is really the same as saying 1/2 power, so I'm actually going to get rid of this square root and just make it a 1/2 power here, and that 1/2 can wrap around to the side and become a coefficient. There's nothing I can do with that first term. And by the way, sometimes you see the parentheses and sometimes you don't if it's just one term. You can drop the parentheses. But here the minus 1/2 stays outside, and then log of 2x can be broken up using that product law into log of 2 plus log of x. And we can distribute that negative 1/2, and we get 3 log of y minus 1/2 log of 2 minus, the minus distributes, 1/2 log of x. Now, eventually it would be nice if you can just go quickly from that problem straight to this last answer by just noticing that any factors on top are going to get a plus, any factors on the bottom are going to get a minus, and then any exponents will just become coefficients. So then you should be able to expand something like this. There's a lot going on here, and I took this problem right out of one of my calculus quizzes. You have to be able to expand this in order to do something to this expression, to this function. Oops, actually, I forgot to put the log in front of it. I'll just put ln right here. I meant to put an ln there. So we have an ln of this expression, and we want to expand it so that it doesn't have powers or products or quotients. So what you notice on top of everything is this square root. And remember that square root means 1/2 power on the outside of that whole fraction. And the ln is still out here. But then the 1/2 power can come to the side and just become a coefficient. So that's the first thing I'm going to do. I'm going to write this as 1/2 times the ln of that fraction. But then what do you notice inside the fraction? I see x cubed and x minus 4 on top. I see 5x plus 2 and 2x plus 3 to the 7th on the bottom. So I'm actually going to skip to the end here. And if you want, you can try to do all the steps separately and then make sure we get the same thing. So the 1/2 gets distributed to everything, but then on top I will have two terms coming from those two factors, ln of x cubed and ln of x minus 4. Oh, but ln of x cubed can be written as 3 ln of x because that power goes outside. Then plus ln of x minus 4. And then the ones on the bottom are going to get a minus ln of 5x plus 2. And then minus, because this factor is also on the bottom, ln of this 2x plus 3 to the 7th power. But because of that wraparound rule, the 7 is going to come outside. You can distribute that 1/2 if you want, and you get 3/2 ln of x plus 1/2 ln of x minus 4 minus 1/2 ln of 5x plus 2 minus 7/2 ln of 2x plus 3. You might be tempted to think that, oh, ln of x minus 4, maybe I can do something to that. No, there's no such property. You can't simplify ln of a plus b or a minus b. I'll just put a question mark. You can't do anything with that. It's ln of a product or a quotient or a power that you can simplify. Remember, we can also use these properties in the other direction. So that's what I'll do next. We want to use these laws of logarithms to combine these expressions, but I can't combine these the way they are because in our laws, there's no number, there's no coefficient in front. I have to somehow get rid of these. So we are going to wrap these back up and make them exponents using that power property or the wraparound rule. You can think of it as putting the cat back in the tree. So I get log of x squared plus log of x plus 1 cubed. And now we can combine these together with that product law, and this gives us log of x squared times x plus 1 cubed. And for this one, you can just leave it like that. You don't have to expand it. The next one has a minus between the logs, so that means, and there's no numbers in front, so I don't have to do the wrapping back up or putting the cat back in the tree. I'll just have log base 5, and this is the quotient property when you're subtracting. We get x squared minus 1 over x plus 1. Oh, but this can be simplified because x squared minus 1 can be factored as x minus 1 times x plus 1. And then the factor of x plus 1 over x plus 1 becomes 1. That goes away. So this is how this ultimately simplifies. And doesn't this look a lot simpler than that original expression? Another property that is useful when you're working with logarithms is called the change of base formula. So this is what it says. It's basically saying you can write a logarithm in any base using a logarithm in any other base by just dividing log of the argument over log of the base. Now, before I use this property to evaluate log base 2 of 20, there is a key in your calculator. There's a menu button you can go to find log in any base. But I also want you to know how to do it with just the LOG and the LN button. But before we use this property, let's just say you were trying to find this value, log base 2 of 20. And so you're trying to see, 2 to what power is 20? I don't know. I mean, 2 to the first power is 2, 2 to the second power is 4, then 2 to the third power is 8, 2 to the fourth power is 16. And then 2 to the 5th power is 32, already too big. So I know the answer is somewhere between 4 and 5, but I don't know exactly what it is. So we say, okay, let's think about this equation. 2 to what power gives you 20? And I'm actually going to do a preview of the next section. To solve this equation, I am going to apply, let's say, ln to both sides. So ln of 2 to the x equals ln of 20. And because of the wraparound rule, I can bring that cat down from the tree, and I get the x on the side here. X ln of 2 equals ln of 20. So then I can get x by itself. Ln of 20 over ln of 2. And that's basically what this change of base formula tells us to do. To find that missing exponent, the answer to this, what should I put on top of 2 to get the answer 20? You just take any log of 20, but we'll use one of the logs that we have on our calculator, like ln. That's my favorite log. Ln of 20 and divide by ln of 2. And you get a calculator approximation. Or you could also do any other log, like log base 10, the common logarithm, log of 20 over log of 2. Now, we're not saying ln of 20 is the same as log of 20, or ln of 2 is the same as log of 2. No, but their ratio is the same, and they both give you the value of log base 2 of 20, which is approximately 4 and we're supposed to write it to 6 decimal places, 4.321,928. Both of these would give you that same answer.